Hello everyone, I'm Aditi Kinkhabala from New LG Institute of Engineering and Technology. Let us start with the concept of stack. So in today's lecture, we are going to see operations on stack and applications on stack. Students, we have already covered push operation and pop operation in the last lecture. Now let us go through peep operation and change operation. So we have seen this push and pop wherein we need to check for stack full condition in while pushing and stack empty condition while popping an element out. Now let us see what is peep operation on stack. So students, if we are given a stack S in form of a vector, right, and top is denoting the topmost element of the stack, this peep function will return the ith element from the top of the stack. Now see students, if we have inserted 1, 2, 3 and 4, what is the top counter? So top will be first of all over here, then plus 1 and currently top will be at the fourth position, 1, 2, 3 and fourth position. So if this is 1, 2, 3, top is pointing to the fourth position. Now, when we say that peep operation returns the value of ith element from the top of the stack, so we will consider I here as index. So if we want to find third element from the top, what is the third element from the top? It means third element from the top pointer. So this is the first, this is the second element, and this is the third element. So based on this third index, at third index, what is the corresponding position on the stack? If we want to find that, we have to use peep operation. Here also students, we need to check for underflow condition. Why? Because if stack has some elements, we can definitely find it. But what if the stack is empty or the index is not available? In that scenario, we need to check for stack overflow. Now, the condition for stack overflow is top minus I plus 1. If top minus I plus 1 is less than equal to 0, we say that stack underflow on peep is there. Now, let us see from this example only what is currently our top. Top is 4. What is I index? If we want to find the third element from the top, in that scenario, our I would be 3. So what is top minus I plus 3? So that would be top is 4 minus I is 3 plus, sorry, this is 1, right? So plus 1. So 4 minus 3 plus 1 is basically 1 plus 1, that is 2. Now is 2 less than equal to 0? No, this condition is wrong because 2 is not less than 0. That means stack underflow on peep is not there. We can definitely find the element. It is present in the stack. Now how to find that element? Now we have to do return S of top minus I plus 1. So again top minus I plus 1 we just calculated, it is 2. So S of 2. What is S of 2 students? So it will return, see this is S of 2. This is the indexing of stack. So S of 2 is 2. That is nothing but the third element from the top. So it will return what? It will return the value which is at S of 2. So this is how we can find element. So we need to understand that index is from the top, right? Now consider this situation. So 1, 2 and 3. Currently top is over here, and when I say we want to find the second index, so that means from the top what is the second one? So top is considered as the first element, and from first element what is the second? So it is the second element from the top, whereas the indexing starts from with respect to algorithm, indexing starts from 1, right? If we consider top is equal to 0. Students, there could be two scenarios where we can have top equal to 0 or top is equal to minus 1. Accordingly, the first element, if top is equal to 0, first element would start from 1. If we consider while implementation top is equal to minus 1, the first element starts with a 0, right? So in this scenario, again, if we say that our top is 3, right? I is the index second position. So what we have is top is 3 minus 2 plus 1, right? So 3 minus 2 plus 1 is again 2. So it is not equal, less than equal to 0. So underflow is not there. So we will return S of 2 because top minus I plus 1 is top minus I plus 1 is 2. So S of 2 is 2, which is nothing but the second index from the top ith one. Right now, in certain scenarios, when I is wrong, that is, if the top is 3 and we are we want index 5, so it is not possible because only 3 elements are there, so we don't have top fifth element. In that scenario, what will happen? Top is 3 minus 5 plus 1, that is minus 2 plus 1 minus 1. And here we can see that even though stack is full, the index which is asked is not found, right? So in that scenario, it would be stack underflow on P. Now, students, the same thing, after finding, if we want to change the value at that particular position, that is that particular index, what we need to do? We need to understand the change operation on stack. Now, what is the change operation of stack? So change operation basically changes. First, it finds the ith element and then it changes it with the new value. So this algorithm requires one stack, top counter, it requires an index, and it requires X. What is X? The new value, whatever user wants to keep it, right? So top again denotes the topmost element, and this procedure basically change the ith value from the top of the stack. Whatever is the ith value, it will go there and it will change that value with the new value which is stored in X. So here the element is not deleted by this peep as well as this change operation. No element is deleted, only value is found out, and in change operation it is replaced, right? Again we need to check for underflow condition. So it is same as peep, that is if top minus I plus 1 is less than equal to 0, it would be stack underflow on change. Okay, students, so now if we have this kind of scenario 15, 20 and 25, so where would be the current top? So current top would be over here, and if we say that we want the third element from the top, so the third element from the top would be 1, 2 and 3. So this is the third element from the top. So currently top is at 3, so third element would be the last one here. So now see how we can replace this value. So let's see first stack underflow. Top is 3 in our scenario and index which we want to find is also 3. 3 minus 3 plus 1. So 1 is less than equal to 0? No, that's why stack underflow change is not there. So we will return the ith element. What is the ith element? Return the element and also we need to change it, okay? So S of top minus I plus 1. So what is S of top minus I plus 1? Top is 3 minus I is also 3 plus 1, which is nothing but S of 1. What is S of 1, students? 15. And now if I place the value of X, which is 50, this X is 50 in our case. So what will happen? This 50 will be assigned to the first element of the stack. So instead of this 15, now we have 50, right? So we have done peep also, and then once we got the index element, then we have replaced that element with the value which is there in X. So this is how we need to we can change any value in the stack, right? So we need to understand the equation is top minus I plus 1. Right? So, and the third step is finish. That is, if we implement it, we need to return the value in the main function. Now, students, let us see the applications of stack. So, we have just understood in the last lecture that it is very important in function calling. What are the other applications? So, the first application is reversing a string. That is, if there is a string here, so how the string will be added? So first of all, one by one, we can add the string. And while popping out, if we print the value one by one, we could get the reversed string, right? Because it works in last in, first out manner. So it is useful in reversing a string. It is also useful in parenthesis checker, right, students? So if there are some brackets inside the equation, right, and if we want to check whether there are proper parentheses and brackets, this can be done using stack. Also, we can have expression conversion. That is, we can convert an expression such as a plus b into infix, where operator is first and then operands, or postfix, where operands are first and then we have operator. So this is very important in order to evaluate expressions. So we use stack. So stack is also used for expression evaluation. If we have a very long expression and if we want to evaluate it, we can can use stack to evaluate it. Also, we have also seen that it is used in function call. Memory management also uses stack. Also, backtracking in certain situations or in certain problems, we need to find out one proper solution from multiple options, right? So we can have some solution, but if we didn't like that solution or if we don't get the proper answer, backtracking is required, and again after backtracking we can go to some other solution or other options. So there are some problems which require backtracking, and for that stack is useful. Also, syntax parsing. So if you must have seen compiler in any editor, the compiler gives error of parenthesis, right? So how it does it? Basically from stack. So if you have, for example, in integer main, so if you have opened the bracket and if you have not closed it, right? If you have not closed it, you get an error. And this is because this is a problem of syntax parsing, which is done by the compiler using stack, right? So these are the applications of stacks.